All right, on to understanding C# at its fundamental basis, as well as its usage within Unity. And this is the first thing you should know in regards to coding with Unity within C#. There is a distinction there. There is a language, C#, just as it is, how it works irrespective of Unity wrapping itself around it. And there is the implementation of it within Unity. You know, the particular ways that Unity emphasizes certain practices and de-emphasizes others. You'll come to find that Unity sort of constrains your programming choices, not in principle, but in practice, which ultimately should make things easier for you, but can be awkward at first. So for example, we'll be going into object-oriented programming with C# because C# is all about OOP, object-oriented programming for short, and the Unity API is built on these OOP principles, but by coding through the API as your interface to this OOP code underneath, some of those practices, those OOP practices, won't make as much sense to use the way you'll come to learn them when learning simply pure C#. So you'll kind of come to know what I mean by this. It's sort of like a dual nature of C# with Unity. There's C# as its fundamental OOP foundation, and there's the implementation of it in Unity through the Unity API as its interface. A lot of buzzwords and funny sounding lingo, but trust me, it's not that complicated. It's just you'll have to come to understand C# and Unity a bit separately. But as we move along, I'll be mentioning where and when the concept I'm teaching you is a fundamental C# concept or a Unity specific implementation of it to help make it a little bit more clear what I'm talking about. But anyways, don't worry about that. That's a little preface, maybe more for you experienced coders out there than you beginners. Okay, so the first thing we'll do to keep things simple, clean, and stripped down so you can really focus on what really matters is we will put aside all that code that we wrote for our prototype for now and instead make a test script that we can use to create code and see the result output in the console. That way we can go through the Unity engine but not get distracted by too many visuals coming at us. Instead, we want to really focus on the code in its simplicity and see the results output just in the text console window that we saw earlier. So in the great tradition of programming tutorials, it wouldn't be a full programming tutorial without a hello world script. So we'll create that right now. You may have seen these before. It's just a demonstration of the simplest way to output a message on the screen. Hello world, because I guess we're pretending that we're generating a conscious machine here. Sorry to disappoint, but we're not doing anything that awesome and sophisticated here. In fact, I don't think anybody's done anything that awesome and sophisticated yet. Not for a while. Anyway, so we're going to want to create a simple test script and go to your assets as you've seen before, create C# script, and we'll just call it test. And remember, in order to output to the Unity engine, we have to attach it to a game object. I could attach it to any game object here, but I'm just going to make a new one just to keep it clean and so we can reference it. We'll call that test. And right now, just right away, I'll drag and drop it there onto my test game object just so it's working. Okay, we're going to want to open that up and write a simple hello world. All right, so let's just make it super simple. Get rid of everything we absolutely don't need to start off with. So, you know, there's just a little bit less clutter. We just need the using engine declaration. Keep that at the top. Don't have to worry about it being a public class, so just delete that. We do need it to derive from mono behavior. We'll go into that a lot later. We don't need an update method, so just delete that and simply write this message in your start method. All right, and save that. Go back to Unity, and remember it's going to output through the console, so there's our "you have been eaten" output that we have from previous. Now remember to make sure to have clear on play selected and these notifications also selected as I have here. And let's press the play button so we can see the output, and there we go. We have hello world outputting to the Unity. Now, as I said, don't worry about all the visuals that are happening in the game. They're ultimately not important. Just look at the console window. So let's look at this code, and it's about as stripped down and as simple of code that we can write and output in Unity. So let's break down this code in a very cursory way and look at it starting from the top and moving down. All right, at the top we have the using declaration. We're using Unity Engine. Using declarations at the top of your scripts are the way that you import pre-written classes of code for use within your current script. So it makes that library of code available within the script if you so choose to use it. And in this case, the script is importing the Unity Engine library of code, which is basically the entire Unity API, its entire code base, in order for you to access it and output back out to the Unity Engine. So for example, in this script, we make use of the log method right here that's found in the debug class, as well as the start method that also we inherit from the mono behavior class. Now, I'm not going to go into inheritance just yet, but just know that that's what this part means. The mono behavior part is inheritance, and the log method comes from the debug class, which we all eventually we get from the Unity Engine reference here at the very top. Much more on this later, just a cursory look for now. And what we'll want to look at much more closely is the class definition we have here. We start with the class keyword, which just tells the compiler that everything within this set of squiggly brackets, which are kind of like the walls of our container, everything inside of that container that we label test is within this class. For now, think of classes in the simplest way possible, which is just a labeled container that keeps things logically separated in code. The same way that you would keep use your dresser drawer to presumably keep your clothes separated if you're good about doing such things. Your clothes can be separated from each other so you know what's contained where. So each drawer would be its own class, if you want to keep this analogy, and you can label those drawers if you're particularly fastidious about such things, sock drawer, shirt drawer, and etc. Now, the only member right now in our test class is the start method definition, which is a different kind of sub-container. Method definitions are special kinds of containers that must exist in classes and contain entire sequences of code or code blocks, if you prefer. And you can see here in this start method definition, we have the log method that takes whatever phrase, string technically, that we pass in between the parentheses that you see here. And somehow, it outputs into Unity through our console. So this is already quite a bit to wrap your head around if you're not familiar with programming. I mean, we're only talking a few lines of code, but here we already have a multi-layered concept of containment or encapsulation in coding speak that's going on here. You got the class container, the outer container, and within that you have another container, different kind of container, your method, your start method, which within it there's a call to another method. So you even have this concept of method definitions, where you have a set of code within squiggly brackets, and method calls, which is actually calling that definition and using it. So you already have a lot to look at here, and it's probably kind of difficult to get your head around right away, and I'm not expecting to, so stick with me and we'll go slow, I promise. So this will be our basic understanding of the way our code will be structured going forward. This will be our common structure. You'll have a class container with some members. Right now we're only looking at methods, and then in those method definitions you will have entire code blocks that you intend to call later in your code, and it will execute in full. But we can't keep looking at this zoomed out kind of bird's eye view and attempt to understand what's going on. So we have to zoom in at some point on each bit of code. So I think the best part to zoom in on right now would be to focus on these method definitions. As much of the code we'll be writing will be within these method definitions. Alright, so you can start off by understanding a method definition as a set of instructions, as I kind of mentioned before. It's kind of like when you buy office furniture and it all comes disassembled, and you get a piece of paper with some written instructions, often poorly, as it were. Now this piece of paper is just the instructions. You have yet to actually use the instructions to put together the furniture. So when we're creating a method definition, we are creating this instruction set, which later needs to be used or executed. You execute those instructions elsewhere in your code by calling it by name, followed by the invocation, parentheses, invoke like a wizard invokes magic. Think of it that way. So in this example, the start method definition calls the log method. The start method itself is called elsewhere. And the log method definition comes from elsewhere. All right, this is all kind of handled by Unity. A little bit too much to go into right now, but just understand that the start method definition that we have here is being called somewhere in the same way that the log method is, you're seeing it being called in the start method definition. All right, actually what I'll do is, why not just make a really quick method definition from scratch and call it ourselves. So why don't we just make a little method that just outputs that message, and so we'll type void, we'll talk about void later, my method, arbitrarily named, nothing in the parentheses, and just put in the debug log message that we had before. And now here in start, I will call my method, I need a new keyboard, I'm so sorry, my method by name, just like that, and save that, and we'll run in a second. So I've created my own method definition with a set of instructions. Actually, it's not a set, it's got exactly one instruction, which is our call to the debug log method with our message in there. And then we invoke it, we call it within the start method, which we then know in turn gets called by Unity somewhere within that vortex. When we create a start method definition, it just ends up piping into some unknown wormhole and ends up on the other side in our Unity display, either through the console or in the game world. And right now we'll see it in the console. So we'll save that, go back to Unity, press play, and no change. It says hello world, so it works exactly the same way on the output, but hopefully that makes it a little bit more clear how a method definition is different from a method call. Alright, so really basic way of understanding method definitions and method calls. A lot more to be said about methods much later. Right now I just want to give you a cursory understanding of how methods are defined and then later called. Just so in the next few videos when we write all these instructions in our method definitions, you have some sense of what's going on with those methods, you know, how it's being piped through the Unity engine. But that'll become a lot more fleshed out, a lot more clear as we move along. So just remember that we write instructions in our method definitions and we execute them by calling the methods by name. So yeah, the next set of videos we'll be writing those instructions and focusing on exactly how to do that. That'll be the heartbeat of much of our coding in Unity. All right, see you in the next set of videos.